Want to know the top 10 .NET Core performance tricks? Stay tuned to discover how to make your applications faster and more efficient. In this video, we are going to explore a variety of techniques, from asynchronous programming to data access optimization, each designed to boost the performance of your .NET Core applications. We'll delve into the specifics of when and how to use these tricks and examine common mistakes to avoid. Understanding how to optimize .NET Core performance is crucial, not only for creating responsive, scalable applications, but also for maximizing resource efficiency. Whether you're developing a small desktop application or a large-scale web service, these performance tricks can make a significant difference to the speed and smoothness of your software. So, if you're ready to take your .NET Core development skills to the next level, let's dive into the first performance trick: asynchronous programming. First up is asynchronous programming, a powerful way to enhance the scalability and responsiveness of your applications. It's like the multitasking maestro of .NET Core, allowing your program to juggle other tasks while waiting for operations like data access or file reading to complete. Now, when might you want to use this juggling act? Well, it's perfect for I/O-bound operations, where your program is twiddling its virtual thumbs waiting for an external process to finish. It's also a lifesaver for desktop applications, keeping the user interface responsive even during long-running tasks. And let's not forget web applications, where async can handle more requests by freeing up threads while waiting for database queries or API calls. Let's talk about best practices. To avoid the dreaded deadlock, use configure await false when awaiting tasks in a library. Always catch exceptions in asynchronous methods to prevent unhandled exceptions from crashing the party. And if you're writing asynchronous APIs, try to expose asynchronous methods alongside synchronous ones, if possible. Here's a quick code example. Imagine you're fetching user data, public async task get user data, or reading file content, public async task read file content async string file path. But it's not always sunshine and rainbows with asynchronous programming. If the task is CPU-bound or involves intensive computation, async might not bring benefits and can even complicate your code. Also, for operations that complete quickly and are not blocking, asynchronous programming can be overkill. And finally, let's not fall into common pitfalls. Avoid calling, result or wait on an async method, as it can lead to deadlocks. Prefer async task over async void for better error handling and control. And when you call an async method, ensure that you handle its task properly, either by awaiting it or managing it as a part of a larger asynchronous workflow. Remember, use asynchronous programming wisely to avoid complications in your code. Now, let's move on to our next trick: optimizing data access. Another key trick is optimizing your data access, crucial for building efficient applications. This is especially significant when dealing with databases or external data sources. By optimizing data access, you adopt strategies that reduce database load, minimize network traffic, and speed up data retrieval. Let's consider when to optimize data access. If you're dealing with large data sets, optimization becomes critical. It reduces memory consumption and improves load times. Applications that frequently interact with databases also benefit from this. And of course, in performance-critical applications like real-time data processing systems, data access optimization is absolutely essential. Here's an example of how you might optimize data access in .NET Core. Imagine you have a database context for customers. You only want active customers' names and emails. Instead of retrieving all data, you can optimize your query like this: var customers =db context customers. This way, you're only fetching the data you need, reducing memory usage and improving performance. However, there are scenarios where data access optimization might not be necessary. If you're working with small datasets where the performance impact is negligible, optimization might be overkill. Similarly, for simple CRUD operations on a single table with a small number of records, you might not need to optimize. But beware, there are common mistakes to watch out for. Overfetching data, for example, can slow down your application. You don't want to retrieve more data than needed. The N+1 query problem is another pitfall. This occurs when your code executes one query to fetch a set of records and then additional queries for each record. Avoid this to prevent unnecessary database load. And finally, ignoring how queries are executed can lead to inefficiencies. Review your query execution plans to ensure they're optimal. Avoid overfetching and be mindful of query execution plans to ensure optimal data access. Let's move forward to our next performance trick. Our next performance trick is about caching. This is a technique that stores data in a temporary storage area, making it faster to retrieve the next time it's needed. It's like keeping your favorite snacks in your desk drawer. You don't have to go to the kitchen every time you want a bite. The main use of caching in NetCore is to improve performance, reduce the load on databases, and make your applications more responsive. It's especially useful for data that doesn't change often but is frequently accessed, like configuration settings or user profiles. Here are some best practices for caching in NetCore. First, choose the right caching strategy based on your needs. You might use a memory cache for data that's accessed frequently, or a distributed cache for data shared across multiple servers. Second, always set an expiration policy for your cached data. This ensures that your cache doesn't keep stale data. Let's look at a simple code example using the memory cache in .NET Core. Public class myService. However, there are times when caching may not be the best option. For instance, if your data changes frequently, caching might lead to outdated data being served. Also, caching adds complexity to your code, so if the performance gain is minimal, it might not be worth it. And of course, there are common mistakes to avoid. Don't cache everything blindly. It can lead to memory issues and can actually slow down your application. And always remember to invalidate your cache when the underlying data changes. Remember to use caching wisely. It's a powerful tool, but like any tool, it must be used with care. In the next scene, we'll dive into another exciting performance trick. Stay tuned. Another noteworthy performance trick is leveraging the power of parallel programming. Parallel programming in .NET Core enables your applications to perform multiple operations simultaneously, significantly boosting the performance of CPU-bound tasks. It's particularly useful when you need to process large data sets or perform complex computations. For instance, if you're crunching numbers on a massive spreadsheet or rendering a high-resolution image, parallel programming can drastically cut down the time needed to complete these tasks. Let's consider a simple code example. Imagine you have a list of numbers and you want to square each number. Instead of using a traditional for loop, you can use the parallel for each method, which will process the numbers in parallel, thus speeding up the execution. However, parallel programming is not a silver bullet. It's not recommended for I/O bound tasks, as it can lead to thread starvation, where all threads are blocked waiting for I/O operations to complete. Moreover, if you're dealing with a small amount of data or simple tasks, the overhead of managing multiple threads may outweigh the benefits of parallelism. As with any powerful tool, parallel programming comes with its pitfalls. A common mistake is to assume that making everything parallel will always speed things up. In reality, too much parallelism can lead to contention and reduce performance. It's also crucial to handle shared resources carefully to avoid race conditions, where the outcome depends on the sequence or timing of other uncontrollable events. When using parallel programming, always remember to measure performance before and after. It's the only way to ensure that your parallel code is actually improving performance and not making things worse. So there you have it. Parallel programming is a potent tool in your NetCore performance optimization toolkit. But as with all tools, it's essential to understand when to use it and when not to. Keep in mind, parallelism can significantly boost performance for the right tasks, but misuse can lead to complex bugs and performance problems. Finally, let's wrap up our discussion on the top 10 NetCore performance tricks. We've explored the power of asynchronous programming, a technique that enhances the scalability and responsiveness of your applications. It's particularly useful in I/O-bound operations, maintaining UI responsiveness, and improving scalability in web applications. Next, we delved into optimizing data access, a crucial strategy when handling large datasets, frequent database interactions, or when speed is of the essence. Remember, these are just a couple of the many performance tricks available in NetCore. Every trick has its place, and knowing when to use them is the real key to mastering .NET Core. Avoiding common pitfalls like overfetching data or ignoring query execution plans can significantly streamline your code. Remember, the key to efficient .NET Core programming lies in understanding and effectively implementing these performance tricks. Happy coding!